In this tutorial, we'll be starting post-processing effects. We'll make a new shader for this because the shader we wrote for the last few tutorials was mainly geared towards models. So we'll start from scratch. And I'll call it tutorial for, let's double click it. So there's just a heads up, this tutorial is going to focus on, is probably going to be pretty short, but what we're going to be writing in these shaders will actually be a lot of things that that you can't really change that much, at least to set it up to its because we're going to try to make a pass-through shader, which basically means that it renders exactly what's on screen. So it basically does nothing, but it will allow us in the future to add things, and we will get to making a grayscale shader as well. We're going to start everything off like we did with the the model shaders. Yeah. So we're going to add the version number. We're going to add this main method. There's a few unique uniforms that we're going to be using. They're different than what we've been using in the past. So I'm back at the vertex shader. We're going to pretty much hammer out this vertex shaders. Don't worry if you don't understand it, because you are rarely ever going to change the vertex shader for a post-processing effect. In fact, I haven't at all, and I don't know of any effects that would, although I guess you could get creative and start doing something like that. It uses kind of like we did with the model shaders. There's actually matrices we have to multiply by to get the appropriate transformation, and these are all uniforms. Actually, these are all matrices right here. Okay, so we have the projection matrix, we have an offset, we have position for the vertices, and we only have four vertices because, like I said in my very first video, we had the way it operates is it basically renders the scene onto quad, which is basically two triangles connected together to form a rectangle. So we're gonna have four vertices. We're gonna have to multiply we're gonna have to multiply by the appropriate transformation. We're going to multiply a vec4 using the position. Let me actually break this down to another line. I wish there was word wrap because I think that'd be easier to see. But anyway, let's do position. We're gonna have to grab the GL vertex ID. Oh, whoops, caps lock. Okay, what's going on? Plus the offset, and then we're gonna do 0, 0, 1, 1. Again, don't worry about this code that much. It's really not that big of a deal, and we're not really gonna be changing it. So, yeah, you can just keep it like this. Now for the fragment shader, this is where the more interesting things happen. So buffer size is the size of the buffer. It's a vector 2, meaning that, first component contains, so your width basically of your buffer, and then the Y position contains the height. So the buffer size is actually could be your screen resolution. We have a bool is back buffer. We just use this for something very simple. We also have a sampler 2D, which is texture 1. The naming of the textures are a little bit different. 1 is actually diffuse, not 0, for post-processing effects. And we have, kind of like our model shader, we have the frag data output, data 0. In Lightworks convention, I guess, there's not really a strict convention, but a lot of the post-processing shaders use something named the coordinate, or the frag coordinate. I chord, which I think is kind of weird because it's not an integer coordinate. Anyway, we're gonna get the GL frag chord, which is the in x and y. So we're basically getting the frag coordinate, which I guess you can think of as close to a pixel coordinate. And we're going to divide this by buffer size. And this will give us a number between 0 and 1 for the x and y. Now we're going to have to... Okay, so we have that. Now we can sample the texture. So texture 1. And we're going to use the I chord to sample it. And we're going to make it color. So let me vec for color equals. Probably should be putting spaces between the equal signs so they're more apparent. Data 0. And we'll set this equal to the color, right? So that seems fair. Alright, this should make some sense. Basically, you're sampling the texture 1, which is the whole screen, how it's been rendered. It's been rendered onto a texture, which we referenced by texture 1. We use iChord to look up what color from that fragment. We get the color, and we set that equal to the output, which is frag 0. So to actually test this, what you have to do is you have to go to scene, root, post effects, add. Okay. So the shader basically flipped everything upside down. This is because if you actually look at, remember with textures, the texture coordinates start from 0 in the top left. When they go right, the x coordinates increases. When you go down, the y coordinate increases. Okay. However, remember in 3D space that actually when you go right in 3D, the x coordinate increases, and when you go up, the y coordinate increases, which is a little bit contradictory to what the texture lookup is like, how you do texture lookups. Okay, so what we're going to do is we're going to do if, this is where the is back buffer comes in handy. Back buffer I chord equals 1. Since it's from 0 to 1, to invert it, we would just do I chord. And now it's inverted, and it looks right. Whoops, actually, never mind. Okay, so we actually have to flip the y. I messed up there. Yeah, the y coordinate. Now it looks right. Okay. Alright, so this is interesting, kind of, I guess. Nothing's really changed, though. It's just what we expected. Now let's, we can do some cool things. I'll just show some really simple things. So if we multiply the color by something like 0.5, we can make the screen darker. See? I want to do grayscale. You add up all the color channels, but by a weighted factor, like this. And you can look this up on like there are actually better equations, and I just picked a really simple representation like 0.2, 0.7, 0.1. It'll be you can find better values for these. Basically, your luminance is how bright something is, and so you see that now it's sort of grayscale. I think there's a little bit of a bluish tint, maybe you can kind of see. But anyway, if you want this to be more precise, you can look up better values. Green tends to have the highest impact on how we perceive luminance, so anyway, that's why it's 0.7. And then, the other colors follow. So that's it for post-processing. This wasn't that long of a video, but I think in future videos we'll talk about cooler effects. Anyway, post below sort of what effects you want to see next, because I'm not actually too sure on what effects to go through next, because there is a little bit of a learning curve for some of the other processing effects.